This is an introduction to a visual organizer that will help us solve force problems. So the name of the visual organizer is called a system schema. And what the system schema does is it represents all of the interactions between objects in a scenario. So I'm going to do a scenario where we have a floor, there's a box on the floor, and we are pulling at the box like that. So, and we'll say that we're pulling, that this is a rope. Okay, so the first thing that we do is we identify all of the objects in the scenario and we put them in bubbles. So you have to have bubbles. You can't just write the words down. So we have a box, and I should say that it's helpful if you, if each object is identified or starts with its own letter. So we have a box, we have a floor, we have a rope, and then an object that is not specifically shown in here but is always present when we're near the surface of the earth is the earth. So that's the first thing you do, is you identify all of the objects and put them in bubbles. Write out their name, put them in bubbles, and try to name them so that each name has a different letter. Next thing that you're going to do is you are going to connect the bubbles if the objects are actually interacting with each other. So we know that the floor is touching the box. So I'm going to put a line there. We know that the box is also touching the earth, or not touching the earth, but it's interacting with the earth. And then we have the box is interacting with the rope. Notice I don't put one between the rope and the floor because the rope is not touching the floor. And you can, I'll put a couple other ones in. We know that the floor is definitely connected to the earth and the rope is being attracted by the earth, but those are not as important as the interactions on the box. Okay, so you put down the interactions. The next thing that you want to do is label the type of interaction. So with the earth, this is the force due to gravity, so we'll do Fg. Box and rope, we have tension force, so we've got Ft. And then box and floor, this is the normal force that is perpendicular, so we're going to label that with the perpendicular force. So the last thing you do is you identify which object you're studying. In this case, we'll say we're looking at forces acting on the box. And so you put a boundary around it. And then the last thing I'm going to have you do is just count the number of interactions. I've got 1, 2, 3 interactions. Okay, so the first thing you do is you represent all of the interactions. Now, the next thing you do, so this is step 1, is you're going to create a free body or force diagram. And this is labeled FBD. And what the free body diagram does is it represents all the forces acting on a single object. Okay, so the first thing you do is your free body is a dot. And this dot represents the center of mass of a single object. And single object. So in this case, it will be the box. There are 3 interactions on my schema, so I have to have 3 forces on here. So when we're building our free body diagram, we represent each force with an arrow Remember, a force is an interaction with an arrow. And then the size of the arrow is proportional to the size of the force. And the direction is in the direction of the force. So we have the force due to gravity, which always acts straight down. So the force of gravity always acts straight down. Now we're going to make a label. So force of gravity is the type. It's on the feeler, which is the box, by the dealer, which is the earth. Notice I use subscript B corresponds to box, and then subscript E corresponds to earth. So my subscript is on the feeler by the dealer. That is interaction 1. I know that I have a tension force that is acting to the right. So this is going to be FT. So force type on the feeler, which is the box, by the dealer, which is the rope. And then I have the perpendicular force going up. In the perpendicular direction, the box is in equilibrium. It is not moving in the vertical direction. And so I'm going to have force perpendicular on the box by the floor. And I know that the last thing I do is put congruency marks when I have pairs of forces that are the same size. So in the vertical direction, those two forces are the same size. I do not have to put congruency marks on every single object. I do not have to put congruency marks on every single object. They don't always go there.